Welcome back. So today we're moving on from just describing inverse relations. So now we're going to learn how to graph them. Now the graphs are called reciprocal functions. So these next two lessons are all going to be about the family of reciprocal functions. Now what do they look like? Well, reciprocal functions take on a parent function like this, okay? Now you may be wondering, why am I using a now instead of k? Well, it's because remember, in the language of transformations, A represents vertical stretches. So that's why we're not using K anymore. We're going to let A represent that vertical stretch, okay? So what do they look like? Well, if you look up top here, there's two branches to each one in opposite quadrants. So a positive A is going to take on branches that look like that. When A is negative, a negative A is going to take on branches that look like that. It's going to reverse where they are. Okay, so that's going to be the general shape of everything we talk about today and tomorrow. All right, just those two branches of curves. Now, some things to note. Now there's two asymptotes. Okay, there's an asymptote at x equals 1, a vertical one there, and a horizontal one. So that's something we haven't come across before, is these reciprocal functions are each going to have two asymptotes for us to deal with, okay? And those move with the shifting. Now, today we're not going to deal with any shifting. I just really want to get you good at the basics. So we're going to see what happens to them tomorrow. Another observation to make is right now, when there's no shifting, notice it's not going to be able to touch either axis. So these ones that have no shifting, so all of them today are going to have no x-intercept and no y-intercept either. Then, like I already talked about, there's two branches, depending on if A is positive or if A is negative. So how do we do this? How do we graph these functions? Well, we need to start by making the table, okay? So x and y values for our table. All right, now look at number 1. So we want to pick x values that evenly divide a. That's going to be the easiest way to make our table. Numbers that divide that value. So I'm going to start with 0 in the middle. 1 divides 8, 2 divides 8, 4 divides 8, and obviously 8 divides 8. Then, of course, there's the negative numbers. So you do want to make sure you're including negative values in these as well. So once you identify all the numbers that divide that a value, now we can calculate the y's that go with them. Okay, now think about 0 here. 8 divided by 0. That's an undefined value. Okay, that undefined value is actually because that is where the asymptote is. The undefinedness, the fact you can't divide by 0, that's what creates that vertical asymptote. All right, then 8 divided by 1 is 8. 8 divided by 2 is 4. 8 divided by 4 is 2. 8 divided by 8 is 1. And then the same in the reverse. So now I have a good collection of points. All right. However, first I'm going to put on my asymptotes, because when there's no shifting, my asymptotes are going to have their homes at 0. So I'm just going to put those on right away before I even start plotting points, because I know that they're going to be there. Now let's plot some points. So -8, 1, -4, -2, -2, -4, -1, -8, 1, 8, 2, 4, 4, 2, 8, 1. And you can see that curvature that I was talking about. All right, so vertical asymptote, when there's no shifting, is at x equals 0. Horizontal is at y equals 0. Again, whenever there's no shifting, that's what they're going to be. So ultimately today, every single one of them is going to have that same thing. Now, what does that mean for the domain? Well, the domain, I can pick any value. I can pick all real numbers except where that vertical asymptote is. I can't pick one there. I can't pick 0 because that's where my asymptote is. I already know that there's no value. Range, same thing. All real numbers, except I can't pick where my horizontal asymptote is. Okay, so that's going to be the theme for these. All real numbers except wherever there happens to be an asymptote. So let's try another one. All right. So y equals -12 over x. So I want all the numbers that are going to divide 12. So I'm going to start with 0 in the middle. So what divides 12? Well, there's a lot of numbers. 1, 2, 3, 4, 6, and 12. And then, of course, all of the negatives. So this one gets kind of a long list. 12 has a lot of factors, a lot of things that divide it. In their center there is undefined. Again, you can't divide by 0, so that's where you know your vertical asymptote is. 12 divided by 1 is 12. 12 divided by 2 is 6. Divided by 3 is 4. Divided by 4 is 3. Divided by 2 or 6 is 2. Divided by 12 is 1. So literally me just running through, plugging each of those x values, 12 divided by that x value to get y. Same thing in this direction. So I know, oh, I apologize. Actually, whoops. If you may have noticed, what did I do wrong? So those are not the values that I'm looking for. I forgot that this is actually -12. So what that means is -12 divided by 1 is actually a -12. -12 divided by 2 is a -6. So this time it's all of these values that end up negative. And up top, -12 divided by -1, this is where they become positive. All right, so do be very careful about that to make sure your signs are correct because it can be kind of easy to mess up. All right, so just make sure you don't do what I just did. Make sure you have the proper signs on everything. There's no shifting. So right away, I'm going to put in my axes or my asymptotes. And now let's start plotting values. Well, unfortunately, these are off of my graph, okay? So I actually can't even use those. So let's start with 2, -6, then 3, -4, 4, -3, 6, -2. So there's my arc, and then back here, -6, 2, -4, 3, -3, 4, -2, 6. And just like we expected, my A is negative, so notice that my branches are in those opposite quadrants, okay? It flipped quadrants. Vertical asymptote, again, there was no shifting, and there's no shifting for my horizontal asymptote either. So their home is always at 0. So the domain, all real numbers, except where that vertical asymptote is. Same thing with the range. The range is all real numbers, again, except where the horizontal asymptote happens to be. Again, I know those are boring today because there's no shifting, but I do want you to get in that good habit, that good practice of labeling them, simply because tomorrow they are going to be more interesting for us. So you do need to understand and be in the good habit of writing them out. So let's take a look. So stretches and compressions of these reciprocal functions. I've given you 3 examples right there. 6 divided by x, 0.8 divided by x, and -4 divided by x. So I want you to think, the vertical stretch and compression, did the asymptotes change? I'm seeing the asymptotes all sitting at 0. So just simply stretching these functions, it doesn't change the asymptotes. It also, therefore, doesn't change the domain and range. The domain and range are only going to change, and the asymptotes are only going to change once we're shifting tomorrow. What did the negative do? Is switch the quadrants the branches were in. That's all that the negative did. Flip-flopped where they are. All right, so let's apply it to word problem really quickly, and then I'll let you get to your summary. So the rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 passengers will be chaperones. If the students who attend share the cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must ride the bus to make the cost per student no more than $20? All right. So 5 of the passengers are going to be chaperones. So that means that there's a maximum of 52 students. So whatever the cost is, the cost is going to be, oops, amongst the 52 students who are going to be riding. Okay, so, oh, whoops, I'm sorry. I have that set up wrong. So, the cost, I'm sorry, we're going to put the cost up there. So, we're trying to divide the 750 amongst how many people there are going to be on the bus. So, now we have the dilemma of the 5 chaperones don't have to pay, do they? So, if we want to pay no more than 20, how many students are going to have to go? Well, we want the cost to be less than 20. So just like we did in the previous notes, to get n, I'm going to multiply the n over first. 750 divided by 20. So really we need a whole person though. So we're going to need at least 38 kids. Now, how many students can attend. So that's where that 57 is important. Okay, so the domain of the function is we need, or we can have no kids up to 52, okay? Because again of that dilemma of we need 5 chaperones, so 5 of those spots are going to be taken up by chaperones. We can only take up to 52 kids. And if we want the cost to be no more than 20, we're going to need 38 students because they're the only ones splitting up the cost, not the chaperones. All right, so thank you for joining me today for that. So write your summary, and again, there's a lot of good stuff you can note, okay? All those facts on the front page, just how to make the table, anything like that will go wonderfully in your summary. So write the summary out for me, and then come back ready to do your practice work in class.